All right. Hi, everyone. My name is Sarvesh Tandon, and this is my project for mobile and pervasive computing, fall 2024. What I built is an edge-native app for indoor navigation. Our key goal was to allow people who are new to the CS building to be able to navigate by themselves using just a mobile application. For this, we used a cloudlet, which is in the CS building, and we built a mobile application. The mobile application sends frames, video frames, and the cloudlet gives it location, gives it the location that it's at, and then it actually announces directions to whatever destination that you select on the mobile application. So the design of the project looks like you have an Android application, and it sends frames via Gabriel. And then the server, which sends images to ORB-SLAM. So ORB-SLAM is an open source project that figures out your current location, and it maps out the area. So you can create a map similar to this one. This is like a subsection of the 6th floor on the CS building. And once you create a map, it's able to detect your location and send you your location. So the Android phone sends the images, the server receives those images, sends them to ORB-SLAM. ORB-SLAM figures out what location you're on, gives it back to the server, and the server will also be receiving a destination from the Android phone. So the Android phone will also say, hey, I want to go to this location. Say you are at this location and I want to go to the other corner. It would give that location, and it would figure out the directions that you need to take in order to reach that destination. So the algorithm is a very simple one. It runs essentially the breadth-first search algorithm. So we've broken down this entire area into basically zones. So there's like a 6115 zone, the 61215 zone, an elevator zone. So you broke this entire map into small areas. And essentially what we did was create a graph of that and use BFS to figure out what direction you want to go to in order to reach your final destination. So for example, you're at 6115, you want to reach the kitchen. I'll show the demo in a second, but if you want to reach the kitchen, it'll give you directions based on running BFS. Now, that'll give you some simple directions along the lines of you should move to this next location and move to that location. The more interesting part of it is actually it gives relative directions, in the sense that if you're coming from 6115 or somewhere around the middle and you want to go to the bathroom, it'll recognize the fact that you're coming from the bottom and it'll say go right. But if you're coming from the elevator, it'll recognize the fact that you're coming from the elevator and say go left. So it gives relative directions, and we use an axis vector math in order to figure out what exact directions to give. So you could be at the same location, going to the same destination, but receiving different directions. And that's based on what your previous location was. So the assumption is that if you're moving from a previous location to a new location, that you are your camera is facing in the direction of the motion. So this is what the app looks like, but I'll show this in the demo. And the key things that we have learned are how do you run Gabriel with ORB-SLAM, and how do you run Docker, how do you build an Android application, and how ORB-SLAM3 really works, and what are the key challenges with mapping out an area. All right, so let's show the demo. So right now, the app is closed, so it's not seeing anything, but it has a version of the map already open. And we'll see what that looks like while we are walking around.
Go right.
OK, so let's say, so I just pick so as you can see, it's recognizing certain points of interest, and it's figuring out what location I'm at. And let's say I pick a destination. For now, I can pick the kitchen. All right, so the kitchen is over there. So we should really go right. But let's say I choose not to, right? For some reason, I make the mistake of just going straight. So it recognizes the fact that I'm going straight instead of going right.
Turn around. Go
back. And it audio, so that I believe this is audible. You're able to hear it say, you should turn around and go back. And it's written there out in text as well. So it's trying to auto-correct all the mistakes that you do. But let's say you still remain persistent and you keep walking forward and keep going straight. Eventually, it'll recognize that the new correct path to reach the kitchen would be to go straight and go take a right and go all the way around, because that would be shorter. So we keep going. We go right because it wants us to go right, and we keep going straight now, and
go straight.
And it's giving us directions based on what direction we're coming from. It uses the previous direction it'll figure out where we want to go. And yeah, so eventually
Go right.
it recognizes that we're at another intersection, tells us to go right. So we go right,
Go straight.
and we go straight, and eventually, once we're at the kitchen, it'll say that, hey,
You have arrived.
you have arrived. And so that's the demo.